Okie doke. Part 2. Lock the shit in. Make sure we don't have music going. Nice. I'm not out of them, yo. Where's the gnat? Damn. Okay. Nice. Nice. Okie doke. Back to it. Another hour and a half. Let's get it. I am going to do what? Well, I just typed the answers in another file. I feel like I kind of want to. Like this. Do I do it in 2 separate spots like this? I guess so. And then I can just open this like that. Cool. We include, how many questions are there? 67? Cool. We include the IO stream, well, we include IO stream to definitions, well, to include, or to, well, to use standard character input and standard character output. Specifically, to include, we're including the header file that has the definitions for the types and objects needed. I think those are called input and output streams, I streams and O streams, but that's the extent of what I've been taught and or remember. Okay. Also good for standard character input dot or standard get lines, so we can read whole lines. Ignore leading white spaces and save save multiple entire line as a standard string, like a whole first name and last name, Ethan Hayes, instead of separately extracting Ethan and Hayes. A isn't valid because can't start, because I'll do full English. Variable names can't begin with a number. B is valid because is fine. C isn't valid, or C isn't valid because subtraction, because operator minus is included. It wouldn't be subtracting 2 though, because it doesn't have a value at first. Yeah. Included. Probably get some sort of invalid error. An invalid error. What if we did yeah, it's thinking we have to finish this definition before we can subtract something. We have to define x before we can subtract anything from it. And pseudo good. What happens if you use using uninitialized variables yields undefined behavior? Because C++ standard doesn't explicitly whether uninitialized variables should be assigned 0 or that or anything else. Could be a garbage value. What was the value at that location in memory before the object was instantiated there, and the value wasn't wiped after instantiation, so the garbage value might persist. Probably we'll get a compiler warning for using an uninitialized object. Inline isn't inline the one that flushes the buffer? Inputs an inline character. Well, that also flushes the buffer. We often don't need to flush the buffer because using standard character output, because calling standard character output, or because inserting value to standard character output will remove the values after reading. Better practice is to use \n, which inserts an inline character without flushing the buffer. More efficient. 5. This is a single line comment. This is a multi-line comment. Oh wait, what? What's happening here? Oh, because this and this. Yeah, alright. Assignment is when, well, initialization is when a object is assigned a value upon its definition. Assignment is when an object is assigned a value after definition, i.e. if we define x via an x, then assign it value later via x is 5, that's assignment. If we instead did in x 5 or in x is 5, we've initialized it with an initializer, the value it is assigned upon definition. 7. Technically, the term for what value an object gets if defined but not initialized is default initialized. The term for the type of initialization an object gets when defined but not initialized is default initialization. Using default initialized objects is undefined behavior because the C++ standard doesn't define exactly what must happen or what value they should get. So the value isn't known. 7. An expression in C++ is I was gonna say anything that evaluates to a result. Is code that evaluates to a result. Five is in well, within if x is greater than 5, x is greater than 5 is a Boolean expression that evaluates, whose evaluation is, or where a relational operation is evaluated to a Boolean value. 5 can be literals are expressions. Expressions can be complex. Well, are they complex? Because complex statements aren't complex statements when there are multiple, or hold on, or complex operations. Hold on, complex something. What am I thinking? Because I'm thinking there's something that's complex when you have multiple statements in a block. Littles are expressions. Objects can be expressions like x, if like x from int x. Operations are expressions because they evaluate to a result too. So you could have two expressions, 5 and x, with an operator between them, this, and that whole thing, 5 is greater than x, is an expression to 8. Put and x is 3, its copy initialized 3, and then we are outputting 5. 5 and an inline character. So 5 and a blank line after where the cursor resumes. 9. Function declarations tell the compiler that the function definition exists, and calls to the function are valid even before the definition. So the definition can exist later in the same file, even after calls to it. This is helpful for including header files with prototypes or function or forward declarations that tell a compiler that the definitions exist elsewhere, which the linker will match up. Function definitions are a function definition is the function's implementation. It's what executes when a function is called. It's required to exist in the program for the function to be called. 10. Void. 11. Wait, what? What is the return type of a function that doesn't return? Non-value returning functions return void, nothing. They execute and no value, or at least an empty value, which is discarded, like a void attack. Can be called via, oops, this should just be attack. Attack without doing anything of the result, because there's no result, because there's no return value. Void it means nothing. That no data is returned by the function, or that function takes no parameters. Haven't used the latter since C++ can omit function name void if there aren't any parameters. 12. Local scope is the scope a local variable is accessible within. Specifically, it's between the variable's definition and the end of the block it was defined in. 13. Header guards prevent including a header files definitions multiple times in the same file, which would yield a multi-definition error. Not relevant if the header file only forward declares things, but relevant if it includes if it has definitions. Forward declarations are variable function object or variable slash function declarations that tell the compiler that notify the tell the compiler that calls to them are valid, even though the compiler hasn't seen the definition before seeing their calls. The linker will link the definition wherever it is in the program to the calls. Prototype and forward declaration appeases the compiler. Namespaces are helpful for preventing naming collisions, as are blocks. Ugh. Is it using declaration or there's two things. Using declaration, I think it's called I'll just call it a using statement. The preprocessor code that is executed before compiling includes a preprocessor inclusion directive. Well, if not defined, something. A mini is checks if something has already been defined via preprocessor directive. And code and preprocessor will Wait, include, define. Yeah, I think it's just regular define, not define. Define. Yeah. What is this like? Object like substitution, where define define string. Well, is it a string? Be something else that takes its place in code. It's the preprocessor will substitute. Okay. Syntax errors are inaccurate or are errors in using the language or the programming language. They yield compiler errors. Like forgetting a semicolon. Semantic errors are faulty assumptions or understandings of the language, like using a variable in the wrong spot, printing instead of decrementing a loop variable, or an off by one error caused by using the wrong relational operator. 19. Stepping into and stepping over are stepping over, breakpoints and value watching are helpful for identifying execution flow, or for identifying a function's execution flow. And what a file's execution flow. Executing code you know works, and stopping at code you're curious about, or you wish to step into over instead of and tracking local variable value changes to see if they match assumptions. Breakpoints are stop points you place at a line of code. So code up to the breakpoint executes as normal, perhaps almost instantly, and executes until you reach the breakpoint where the debugger starts. You to step into you to start debugging. Call stack shows you which functions have yet to resolve, i.e., we might be in function A called by function B called by main. A has to return, then B, then main. Shows you how deep you are in a program and what's left for its completion. As time in programming is spent debugging after writing code, identify the issues first to save time. Or yeah, to avoid wasting time later. Excuse me, find issues before they become problems. Finding an issue before it becomes a problem, by definition, prevents a problem. That's good. Make more, take the time to make resilient error, input validating error handling code. Make it work. Yeah. Size of returns the size t number of bits of a data type. Size of int likely returns 4 for regular Windows systems or regular Time64 systems. Or well, I guess yeah. Ints split memory half between smallest half in positive, half negative. Unsigned ints are all positive, with 0 as the minimum. Can't a loop decrementing that decrements an unsigned int until it's less than 0 will be infinite because of modulo wrapping. Unsigned ints can't hold negative numbers. Unsigned ints yield unexpected missed behavior and are a pain. Apparently useful for bitwise stuff, probably for efficiency because an unsigned int can hold more positive integer numbers than a regular int, than a signed int. Decrementing subtraction will yield errors for unsigned ints that signed do not. Size t. Well, so the size of an operator, are you sure? I guess so. I guess it's a unary operator. Define the size of a variable or data type. Maybe you don't know. Type an object is later, or what size an object is later on. So you add code to check or validate, or well, to confirm. Floating point literal and scientific notation. What? 3EF or 3E8F, right? Would that work? just say 3e f f. E is the times 10 to the, or well, times 10 to the something. $28. Okay. How long are we going? 30 minutes? Not even long. Okay, cool. I got time. The value of a Boolean variable after the statement. B is 5. It's 1. True. None. Guys are converted to 1. And converted into a Boolean. 0 stays 0. Using after executing standard character output bool alpha, or standard bool alpha, will be true in this case. Oh, wait, character C? I'm pretty sure it's gonna say the number. Pretty sure standard character output. Well, actually, no. It's just that unsigned ints will be the character. Wait, isn't it just C then? I'm pretty sure it's just C, or it's just A. And yeah, like, are you tripping? Right. Okay. Const qualified variables aren't aren't guaranteed. Well, the compiler is guaranteed to treat const expression qualified variables as known at compile time, and will optimize them the most. Substitute their expressions for their literal values, since They're unchanging and known at compile time. Also possible for const qualified variables, but not guaranteed. Const variables can also be externally defined, while const expression variables require definition when declared, or will require initialization at definition. Can't say x during const expression something. Okay. Oh, a hexadecimal integer literal? Isn't 0x? 0x something? Isn't that how that works? So we say like 0x16, and that would just be f, I think. Oh, oops. Wait. Oh, it's printing the numbers. So it's gonna print, in this case, 1 is 16. 1 is like 256 plus 16. So what is that, like? Isn't that what's happening? Wait, what? Oh, wait, no, hold on, wait. 1 is 1. 12. What? Oh, because that's 16 plus 2. So this is like C is 13. Oh, wait, no. Well, yeah, something like that, I think, right? 12. Oh, because 9A is 10, B is 11, C is 13. So if we say 111, that's some big shit. Yeah. Oh, because that's ones. This is how many, or so this is up to, so this is the, like, this is 16 or not, and then this is, oh, so this is the ones, and then this is how many 16s there are. So this could be, so if we said 21, that's 33, I think. Yeah. All right, cool. So that's the 16s place, that's the ones place. How many ones are there? How many 16s are there, etc. 3. String literal. It's just the sequence of characters within or between the quotes. Standard string view is useful to optimize using standard string. Copying and return, or well, yeah, copying standard strings is expensive. but we can access the values. We can read-only access the values by returning a standard string view to the standard string object or string variable, or assign a standard string view to be that to point to that standard string variable. We don't need to copy a standard string as a parameter for a function if we just need to read it, cheaply read it. As if? Fuck, what is an as if rule? Fuck, I don't know that. What? Well, why really? 0.1, 0.1, and 0.1. Like, there shouldn't be rounding errors, dude. Uh-oh. Oh! Never mind. I lied. What? No. Precision isn't here. I don't know where set precision is. Damn, I thought that might have been it, but no. Well, I mean, because there's got to be an implicit conversion here. Because the relational operators we learned earlier are where these implicit conversions happen. Or where these arithmetic conversions happen. So it must mean that the integer is converted to a floating point. And it means that the 3 point... The arithmetic conversion. I guess it thinks isn't equal to the 0.3 that... Oh, well, no, because we're not talking about an integer here. We're talking about 0.3 plus 0.3 plus 0.3. And then 0.3. There's no arithmetic conversion here. Because they're both doubles. I'm really not sure. I have no idea what the as if is. Fuck. Excuse me. Oh, fuck. Alright, this is what I wanted. The bitwise and wait, is it? What's the fucking operand? Or no, it's not or and. That doesn't make sense. This or this. Assign it to be this and this. Or oh, we could. Wait. I think 1011 to decimal. Oh fuck. So this is 1 plus 2 plus 8. 1 plus 2 plus 8, so it's 11. Formula or an expression could be oh, there were different ways, I think. Different methods of doing this. would we make an integer that? So we convert it into decimal. Did we have to do standard bit set and then say, and get that index and say, hey, if that's true? I think we could, and I think we did. I learned loops and shit later. Have a loop, checks each index of the bit set, depending on the index, and if true or not, adds to an integer, which eventually prints as decimal. So like, how would that look like? We'd have, what, like 4 each length of the bit set? So we pass it the length of the bit set, so we could say it's 4 bits. Okay, cool. I'm gonna say while the current bit while the current bit is less than, so we start at 1, current bit is 1, and while the current bit is less than or equal to the bit number, so it's 1, 2, 3, and including 4, so we don't do 3 and get a 1-off error, 1-off by 1 error. And it'll say if or well, we could do the bit set index at the current number. Oh, we could actually start at 0 and then just say less than. That makes more sense. And we could say the current number, or the bits, the bit size minus the current number. So 4 minus 0 is, oh, actually no, because we would want to get the final index, and I think that would be 3. So yeah, so we'd say, we'd leave it 1, 2, 3, 4. Okay, so we say the final index of size 4 is 3. So to get it, we say 4 minus 1, so that's total size minus the current, and then the next one would be the total size minus the current, so 4 minus 2, which is 2, which is the third index, 0, 1, 2. And then we say, hey, if that one is this, or well, we could say, yeah, if that, then add 1, else add this, if this, add this, if this, add this, or else add this, or if this, or oh, we could just have conditionals. So this integer starts at 0 and it is plus equals, is this index true? It is, add 1. Otherwise 0, and it's plus equals, so it's itself plus 0 or plus 1. And then the next one is itself plus, hold on, 0, 1, oh, or 0, and it's this one plus 2 or plus 0. So it could be 0 plus 2, it could be 1 plus 0, it could be 1 plus 2, and then plus the next, and then plus the next. And then we could go all the way up until the whatever the maximum size of the bit we have. We could have a loop that executes for each index of the bit set we're using, maybe up to 16, size 16, and while the current index is assigned 1 is, or well, assigned 0 is less than the total size, do a assign an integer plus equals itself plus equals a ternary expression, or the ternary operator the result of the ternary operator of a ternary expression that assigns the value of each place. If the first place isn't true, it adds 0. If true, it adds 1. Second place, add 2 or 0, etc. So it could be 0 plus 0, or 1 plus 0, or 1 plus 2, or 0 plus 2 to get 0, 1, 2, or 3 for the first 2 bits. Oh fuck. Number 7. Variable shadowing, or shadowing is when the current scope defines a variable already defined in outer scope, and calling it defaults to the current scope one. Call the global variable, or call the global version, or global counterpart via to access, or to bypass the shadowing. Internal linkage means an object or function isn't visible to the linker. It can't be forward declared in another file. It can only be used in this file, because the linker can't link it elsewhere, and the compiler won't know it's valid anywhere, or it won't, and it'll be invalid elsewhere because the linker can't link the definition to the external forward declaration. 49. Global variables are accessible everywhere, while local variables still have local scope. Their lifetimes are the same. Static. Created upon program start, destroyed upon program completion. Global variables are initialized upon creation. Static local variables are initialized upon definition, and given 0 or upon creation, but they're true initialized value upon initialization. Inline, or global constants need to be extern qualified. They can be forward declared elsewhere, telling the compiler that their calls are valid because the external definition exists. Inline lets us define variables, or well, hold on. define variables and functions. Well, does that matter? Okay, ran out of brain for the music. No longer able to blur it out. And the reason it's useful for inline files or inline variables is why. So you can have one place. The difference between that and just defining a variable somewhere and then having to forward declare it everywhere, is it just more convenient to include an inline const expression version? Oh, well, if we're doing it the other way, that we can't. Okay, so if we want a const expression variable to be, or if we want to access a const expression variable in a file, it needs to be inline qualified. We can include it without violating ODR. And inline require, well, yeah. Okay. Unnamed namespaces. What the fuck's the point of these guys again? Aren't they just ways of avoiding name confliction or collisions? Fuck, I don't really remember. We have a namespace and we have another namespace inside it with something. Those things are defined, I think, back in the parent scope. I don't really remember the purpose though. Point of an unnamed namespace? If we have a namespace and we have two separate it's like block scope in a namespace, but not really. What is the point of an unnamed namespace? I really can't remember straight away. I'm gonna have to extend how long I'm doing this for. While loops don't have to execute, or won't execute if the condition is false first. Do while loops will, as they do first, then evaluate. Break exits the most internal loop we're in. Continues to the loop, next iteration. Or exits if we're at the last already. Let's just check for specific values via cases. If statements are better for checking ranges. For bulk, checking specific values, switches are more consistent than if everything. Oh, oops. Seed a Mersenne twister with a seed sequence, probably initialized with standard chrono steady clock and 7 calls to random device, because Mersenne twisters have 8 seed variables, I think. Call a uniform int distribution initialized from 1 to 6, with the Mersenne twister object as its argument, like handle invalid input, check if standard character input, or check, see if it failed. If it did, reset it via standard character input clear, then call a function that calls standard character input dot ignore, that uses the max value of a output, or of a stream, so a standard stream size, and the inline character, or inline character, to clear all extra, or clear the invalid input and anything after. Stream size thing would be standard numeric limits, standard stream size. Oh, max. Yeah. 61. Assert calls standard abort. Yes. We'll mix this with code 3. Okie doke. If its condition is false. If static assert is executes at compile time, while assert executes at runtime. Static assert condition must include const expression values only. Implicit type conversion is when a value of a data type is passed to or is assigned to a variable or passed to a function returned from a function of a different data type, like returning an unsigned int, like returning an int for a function that returns an unsigned int, or assigning an int an unsigned int value, or passing an unsigned int to a function that takes an int as a parameter. Narrowing conversions are when the data type we're passing is not, the data type, the target object cannot hold all values of the data type that is being converted. Like a float receiving a double, where the specific float being assigned the value of a double variable. We can bypass this if const expression and the assigned value is within range, value can be held by the target data type. Like if 5.0 was the doubles value in this case. 5. List initialization prevents narrowing conversions. Except with the precision part right there. Well, prevents narrowing conversions, at least flags them as warnings. Static cast is used to explicitly convert a data type to another. and the compiler won't generate a warning because the user is explicitly doing the conversion and should be aware of the potential narrowing conversion. 67 arithmetic conversions are during operations where the types are to determine the data type of the return value. Are operations conversion to determine the return values data type. Oh my god, this scared the fuck out of me. I gotta continue. I gotta continue though. Tomorrow. Who knows? Who knows what I'll do tomorrow? Alright, gotta continue. Haven't looked at the answers yet because I need the as if and some of the other stuff. As if and the unnamed namespace, and I think that's it. Excuse me. If we're like, what value does adding two shorts yield? An int. Why? There are usual arithmetic conversion rules that only include int, long, float, double, and long double. So, data types not included there, or that rank under those are promoted. So short gets promoted. It gets numerically promoted to int. The two ints are added, then the return type is the common type int. Same for adding an unsigned int and an int 64. An int 64. Let's see. So the unsigned int doesn't outrank or equal the int 64. The int 64 is a long or a long double. So that int is less. And the value can be held. So I think the unsigned int is converted to an int 64. Since an int 64 can hold all values of the uint 32. The uint 32 is a lower rank. It's a lower rank. Okay. Bam. Oh my god. Oh, is that a lot of text? How much text is there? Oh my. Oh, well. Was it really that long? Bro. Oh no. I wanted it to just respond. Oh no. Oh fuck. character counter. So if I do that, oh shit. Okay, here we go. Okie doke, we're cool. Oh, the new line, the buffer flash, Y is preferred. Single line, multi-line. Default initialization. Line. Difference in the role of the linker. Void functions that return nothing. Scope boundaries. Header guards. For declarations, preventing naming collisions. Namespace. Scripts over. Make sure. Okay, here we go. Cool. All right. Differences between those types of errors. Debugging tactics. Yep. Breakpoints. Call stack. Yes. Tracking how deep we are. I mean, makes sense. Size of operator. Int and unsigned int. Yes. Unexpected. Size T is used for sizes and counts. What is a size T for? It's finding the size of... Meaning counts? What do you mean the count? If I want to find the size of an object or a data type, we can find that. Oh, but a size T will also return the count, like the number of indices for an index, I think, or for an array. F 0 outputs a character, yes. Converts that to a double, yes. Compile time guarantees external linkage, yes. Oh, the as if I think is as if it was the literal. I think that's. Oh wait, never mind. Alright, sorry. Totally wrong. Yours are probably dead. Yes, read only access to those. Cool. The as if means the compiler can do whatever the fuck it wants as long as it doesn't change behavior. As if. Why is it called as if? So it's as it wants if it doesn't change behavior. I think that's what it means. In any way, as long as if it doesn't, as long as the behavior of the program doesn't change. Program can optimize as it wants. As long as the behavior doesn't change. As it wants if the behavior doesn't change. Constant expressions evaluated compile time, precedence, the order of operations, yes. Prefix and postfix, cool. Oh. Logical and operator, cool. Oh shit, maybe? Represents 8 bits, can print as binary. Alright, so it's an 8-bit integer. Correction, 5 and 3 is a bitwise AND of the numbers 5 and 3, which yields the ones that they have. So we say we assign something 5, or this unsigned int is the unsigned int, and I thought there was a another bitwise operator though that we could do the same thing. Like we assign it like it like an equals and something else. So it's the shit that is in common with something else. So in this case, ones is the only in common one, so it yields it like this. So we could say like 7, which is 0, 1, 1, 1, and 4, which is 0, 1, 0, 0, is 0, 1, 0, 0, because that one is the only one that they share, which is in binary or in decimal 4. here. 7, 0, 1, 1, 1. Or 4, 0, 1, 0, 0 is 0, 1, 1, 1. It's all this. Oh, it's actually. No, because it's returning the ones that are true in both. That's how it is. Oops. It's a bitwise AND. So the bitwise AND doesn't return true or false. It returns the binary. So we could pass the binary guy and the binary guy, and it will return the binary overlap, or the binary overlap of both or either. Shadowing, scope and lifetime, global constants. Oh wait, what? Hold on. Sharing global constants. Oh, global constants. Global constants meaning const expression variables. Well, meaning variables we want to access everywhere. And we don't want them to be constant. Well, we could do an extern constant variable to define it in one spot and get it everywhere. But it's not necessarily known at compile time. To get it known at compile time, we make it inline const expression in a header file, in a header only file, and then we just include it everywhere. Is there a shorthand for assigning an integer a binary variable the and return the result of itself and another, or for another, like x equals and, or x equals or must you do x is x and y, or x is x or y? Can't remember all the mask procedures to update to more efficiently use and update booleans via uint8 or standard bit set 8. Okay, so yeah, you could do inline there. For unnamed namespaces. Oh, wait, an unnamed namespace. So a namespace. Wait, really? It gives internal linkage to something. So if you do a regular namespace to something, namespace something, and then blah blah blah. Oh, the point is that the only way to access it from other places is to do namespace something, because that namespace something is known in the compiler, because you've included that motherfucker. But if you do a namespace that's blank, and we include a namespace, then it's wait, really? It's internal linkage? Because I thought that it went to the parent. Oh, it does. It goes to the parent, but you can only access it in that file. Ah, so you use it to make some things in a namespace have internal linkage, but in bulk, instead of making them all static functions or const qualified, might not want to for variables. But in bulk, can't including the header file that includes that namespace won't include them? Guess not. So unnamed namespaces are like, hey, I have a namespace and I got a bunch of shit in it, but then I have some other shit and I want this to only be accessible here and maybe encapsulated or something. Then, boom. Put it in a namespace with no name. All versus do while, Merson Twister, cool. Okie doke. Oh, and equals or equals, motherfucker. And equals y or equals something. And then XOR is, I don't even fucking remember, bro. I don't even know. I don't know what this even is. It's like some kind of crazy shit. There's no assignment version for bitwise not. So you have to do it. You can't do equals not. You gotta do it is assign the value of not it, which will flip it. And if you wanna set clear toggle to set them, you set the or. So it's the stuff that is similar in both. So it stays the same and it turns on the bit that is positive in the flag. But if you do and, it turns off. Well, you turn off, you need to do the one bit. You don't want to do the whole thing. Clear bits. You don't do the whole thing. You do the same one. Or, because if you do the whole thing, toggle bit, the flag. I don't remember how you access the specific bit. Unnamed namespaces give them to modern alternative to using static at file scope. Well, the variable part wouldn't work. Including a header, result in each file having it. Yes, because they're unique. Interesting. Use an unnamed namespace in CPP files. Oh yeah, because we only want it there. We don't want to include it if it's internal linkage. That's like including a static function in other places. Oh, we would get... Wouldn't we get the multi-definition error? Yeah, it's dangerous, yo. Well, no, because if it has an unnamed namespace in it, if you had two different CPP files, and they both had unnamed namespaces, and they both had functions that were static, yeah, you'd have unique shit. So if you want to access global stuff within it, maybe you don't do that. Or yeah, because we're talking about global stuff that's somewhere, and we maybe access it through a function somewhere. We want to access the copy that is stored in this CPP file. We don't want to access the one that's copied in this one file that's using it. We want it to be stored somewhere, and we use some stuff to access the static stuff. But everywhere is accessing the same shit. We don't want to include this guy in different ones, because then if two different files are using something to set the attack damage or whatever, and the attack damage is within an unnamed namespace, it's only setting the one in this file. And this one would only be setting the one in this file. Okay. We could do and equals and or equals. We could do and or we could not. We update a specific flag, specific bit for bit number n. Bitwise operation. So we are... What is this? Is it like changing its value to 1? So we're accessing bit number n. 4 equals 1. this is the third, this is bit 3. This isn't extracting. Well, it's not extraction or insertion. It's the bitwise something else. Isn't this like the bitwise shift? Mask 2 is this. This is for bit 2, 0, 1, 2. And if we have this flags guy that is 0, 0, 0, 0, 0, 0, 0, 0, and we set them to be or assigned mask 2, what's the point of this shit? Somehow this yields that? Is 1... Oh... If we want to turn on the third one, then we are... Are we taking 1 that is 0, 0, 0, 0, 0, 0, 0, 0, 1, and shifting it to the right? Let's say we're doing the first one. We shift it to the right. Or we say, if we shift it to the right 0, then we set it to be that one. But if we shift 1 to the left 1, then we can access the second one. So if we want to change the 7th one, then we do, let's say it's 0, 0, 0, 0, 0, 0, 0, 0. And we want to update the 7th one. Or, well, which one is that? Yeah, I guess the 7th one. We set it to be the result of itself and the result of itself or another one. So what's true in itself or the other one, or what's true in itself and the, or well, yeah, what's true in itself or the other one. So if it's true in here or here, it's true in the result. And we shift 1 7 times to access the bit. So 1 is in 0, and then we shift it to be the 2, the 3, the 4, the 5, the 6, the 7, and the 8th. So we shift it 7 times to get it over into the last spot, from the 0 to the 7th spot. So we shift it 7 times. And that sets that. To turn it off, we shift this guy to get where it is. And we set it to be itself and not it. So if we shift 1 to wherever we need it, and then we turn it into a 0. So I mean, I guess you could technically shift 0 to wherever you need it, or you could just say not. So you shift 1 to where you need it and say not it. Oh, actually the whole point is you flip the whole thing so that it goes from being 1 0 0 0 0 0 0 to being 0 1 1 1 1 1 1 1. That way, when you set it to be and, all the other things are true. So the only ones that were true in yours and there, so the only ones that were true in yours stay true. You're not flipping anything else. But the one that was true is now 0 there. So now that one goes to false. And then the toggling is somehow like that. Okay. All right. I think that's close enough. I think I figured out the strat for doing this kind of stuff. What would happen if I like did some commit shit, huh? There's some changes. Let's just commit all. What do we do? Self-test through narrowing and arithmetic conversions. Commit all. Save changes. So what if I save and then commit? Boom. And then what if I view all commits? And then I could revert. There's been one change. Okay. That is good enough for me today.